question. Ready? Y in smaller form equals 6,500 bracket 1.06 to the x. Now, what this is talking about is y is population of fish and x is time in years. What I want you to tell me is, in this situation where y is the population of fish and x is the time in years, what do the two numbers stand for? I want you to give me an explanation. What does the 6,500 stand for? And what does the 1.06 stand for? What does the 6,500 represent? What does the 6,500 represent? Yeah. The initial population of the fish, right? Now, if I said the population of the fish, if I change this to population of the fish in 2003, if I put population of fish and then say I had said 2003 instead, added that, then I would say that in 2003 the initial population of fish is 6,500. Correct? That's all that means. It's just the initial population in that year. What does the 1.06 mean? Yep. Yes. So what you actually have to explain it to make sure that you're explaining thoroughly is that because 1.06 is greater than 1, the population of the fish is increasing. And how much more is it than 1? 0.06, which is what? 6%. So this population of this fish is growing at 6% per year. Right? That's how you have to explain it. And it's increasing because it's greater than 1. Make sense? So you have to explain those things. Okay. What if I give you a petri dish has 6 bacterial cells in it. It doubles every 4 hours. How long to the nearest hour will it take for there to be at least 20,000 bacteria? I want you to set up the equation. I want you to solve it with using your calculator, and I want you to solve it by converting to a log, both solvings. Okay? Try it out. Make sure you write it down. So what is our final? What's our final? 20,000. What's our initial? What's our rate? 2, because it doubles. If it's tripled, it would be 3. If it halves, it would be 0.5 or a half. Then it says it doubles every 4 hours. So is that the time to reach final or the period? Period. Because it doubles every 4, every 4, every 4. So making us find t. Now what did I tell you should always do first when solving? Yes, divide the initial over. So we'll divide this 6 over. And then we'll get 10,000 divided by 3 equals 2 to the t over 4. Now we could y1, y2 this, correct? But when we get it to this point, how can we always solve it algebraically? Convert it to a log. Yes. So the formula for converting to a log is on your formula sheet. It's y equals a to the x, double-headed arrow, x equals log base a of y. Do I have it as an exponent or a log? It's an exponent. It'll always be an exponent. So I line it up with the exponential one. So y is the one by itself, a, x, and then I have to convert it to x equals log base a of y. So it's going to be x, which is t over 4, equals log base 2 of 10,000 divided by 3. And how do I get rid of this division of 4 to get t by itself? Multiply by 4. This whole thing. So everyone type that in. I don't have a calculator. I can't even type it. Maybe this one, is this one fully dead? It keeps telling me it's dead, but I don't know if it's... Yeah, it's fully dead.
How do you put the one in?
Math, arrow up. This Thursday's going to be real good. It's going to be a solid showing. I can feel it. So excited about marking it.
Being honest. 10,000.
What do you get?
I got 46.8.
Oh, I didn't like
46.81. So what would that be to nearest whole hour?
47.
27.
You're saying it was 12 hours? I was like, what?
Okay, what if I give you this one?
I'm scared.
Sam invested $4,000 in an RRSP AA at 4% per annum, that's just per year, compounded semi-annually. How long to the nearest year will it take the investment to double? Remember the formula for this one is final equals initial, bracket 1 plus I divided by CP, n times CP. So what's the final? Because it says 2 double. That's the initial. That's what he invests. 1 plus what's my interest rate? 0.04. Compounded 2 because it's semi-annually, and we don't know times 2, correct? So we're going to divide our 4,000 over. We always divide our initial over. So we get 2 equals 1.02 to the 2n. We agree? What can we do at this point always? Convert to a log. Convert to a log. Or y1, y2, technically, if it was a Robert response. So y equals a to the x. X equals log base a of y. So we're going to get y, a, x. So you get 2n equals log base 1.02 to the y, which is a 2. And then how do I get the 2 away from the n? Divide. And what does n equal? Anyone get it? I don't have a calculator, so. We'll wait. How much?
Oh, wait, times 2.
Divided by 2.
Yeah.
So 18 years. You guys swap your handings and stuff. Okay. The next things I'm going to give you is I'm going to give you solves. Remember, if there's a variable beside the base of the log or in the base of the log or beside the log, you have to convert to exponential to solve it, correct? If it's an exponential equation and the variable's in the exponent, you have to convert to a log to solve it. And you need to have 3 pieces in order to convert it to a log or to exponential. So sometimes you have to divide things over in order to get them into the 3 pieces. So I'm going to get you to solve the following. A, 3 equals 6 log x, and then 2. B, 2 equals 4 log 3, 2x plus 1. What are we going to have to do first before we can solve these? Divide the 6 over, divide the 4 over, right? C, 3 to the x plus 1 equals 4. And D, 2, 4, x plus 6 equals 10. You solve those up in the other review. So here, what's the first thing I have to do for A? Divide the 6. So I get 1/2 or 0.5 equals log base x of 2. And then I have to convert to exponential, right? So the formula for exponential conversion is y equals a to the x becomes x equals log base a of y. Remembering this is on your formula sheet, so you don't even have to memorize. Now, these are logs, so we have to line up with the log one. So this is x, this is a, this is y, and we're converting it to y equals a to the x. So it's going to be 2 equals x to the 0.5. How do I get rid of a 0.5 exponent? You can just take the 0.5 root if you really want to, right? It looks really weird, but you can do it. You can go 0.5, 0.5. So you go 0.5, math, I think number 5, and it gets you that 0.5 in for the x. And so if you do that, what's 0.5, the 0.5th root of 2? Or it's technically 2 to the 2, so it should be 4. Did you get 4? You can y1, y2 it as well, right, at this point. But honestly, if you just have if it's a square, you take the square root, right? If it's a cube, you take the cube root. If it was 0.5, you take the 0.5 root. Still works. B is going to be the same deal, but we are missing what's beside it, so we divide by 4 first. And we get 0.5 equals log base 3 of 2x plus 1. And then we line it up with the log. So it's by itself is x, log base a of y. And then I get y equals a to the x. That's the formula I'm going to switch it to. So I'm going to get 2x plus 1 equals a, which is 3 to the 0.5. Then I have to subtract 1 from both sides. So I get 2x equals 3 to the 0.5 minus 1. And then take that answer and divide it by 2. And what do we get? I don't know, what's 3 to the power of 0. You should be typing it in. Because if you can't type it in, good luck. Godspeed. And it's not going to be pretty. What'd you get? 0.37. So we need to make sure we can type it into our calculator, because some people will get to that answer and then they're stuck. You don't want to be stuck on just the typing it into your calculator portion. So these are exponentials. The moment you have an exponent in the variable, or variable in the exponent, exponent in the variable, oh my gosh, variable in the exponent, you're going to have to convert it to a log if you can't make common base. Remember we did the common base thing too? So this is y, this is a, this is x, and we have to convert it to x equals log base a of y. So we're going to get x plus 1 equals log base 3 of 4. And then I just have to subtract 1. X equals. So type that one in. Log base 3 of 4. Enter. Close your bracket. Or just hit enter. And then minus 1. I got 0.261, is that what you're saying? Yeah, yeah. 0.26. And could I y1, y2 this to see what the answer is so that when I'm done I can check it? I can always y1, y2 all of my originals. Get what the answer is and then I'll know if I'm right or not, right? I can check all of these. D, I have to divide the 2 over first. So I get 4 to the x plus 6 equals 5, and then I need to convert y, a, x. The conversion is x equals log base a of y. So I'm going to get x plus 6 equals log base 4 of 5. And then I have to subtract 6. What do we get for this one? What do you get? Some of you don't even know how to type logs in anymore, so I would be trying it out on your calculator.
Negative
8, 4?
Yes.
Perfect. If you're not trying it out on your calculators, I'm super sorry and worried for Thursday. Actually, I don't even want to mark your test. You guys got to practice, right? I know you may be happy with your mark, but it just makes me sad when I mark it and it's a failure. Then I feel like I'm a failure. Okay.
I mean, but you taught us everything we need to know.
Yeah, but
It's our fault.
It's really, really our fault.
it's not how it feels when you mark it. Okay. I want you to solve this one.
What's my like a gift card on the back?
Like an I'm sorry?
Yes.
Oh.
Sorry.
Should have done better? Is that what it, the should have? Oh, should make it better.
No, I'm not expecting that. I'm just saying, hey, I'm sorry I'm so bad in class.
Okay, what's the difference between E and the previous ones? How could we solve E? They're exponentials. They have 2 exponents. And the moment they have 2 exponents, I can only ask you to solve it one of 2 ways. Your calculator is one, but I can actually ask you to solve this one algebraically. Make it both be base
Oh.
2. Base 2. Try it out. 8 is 2 cubed, right? So 1 over 8 is 2 to the... No. 8 is 2 cubed. 1 over 8 is 2 to the... negative 3. Remember you raise it to a negative to get the number to pop up?
2 to the negative 3.
Is 1/8.
Okay, enter. But you're right.
I know, thank you. Thank you. Because a negative exponent makes the number flip.
Oh.
You can move your denominator to your numerator when you have a negative. You don't really remember that because I have grade 10, but you know. So this is 2 to the negative 3, this is 2 to the 2. Try it out. Oops. So we have 2 to the 4x plus 2 equals 2 to the negative 3x plus 9. And then when I have the same base, I can write my exponents equal. So I go 4x plus 2 equals negative 3x plus 9. And then I told you when you have an x on both sides, if you're spending more than 3 seconds figuring out which one to move, you spent more of your life you're not getting back. Pick one and just move it. Convince yourself, okay? I'm going to move the negative 3 because I like adding, but I could move the 4 over. It wouldn't matter. Just pick one of them and make them combine. So add 3x, and I get 7x plus 2 equals 9. Subtract 2. 7x equals 7. Divide by 7. X equals 1. And then you can y1 by 2 to check it, right? Do you want me to do one of the log laws where you have to put them together? The different logs, same base? You want to try that one too? Okay, we're going to do simplify. I'll leave it here. Simplify. Simplify that one. Okay, so what we're going to do is we have to take the exponent and draw it up because we have to have plus or minus ones in front. When we have plus or minus ones in front, remember whenever they have the same base, it screams, put me together, right? Anything with a plus one in front stays on the top. Anything with a minus one in front stays in the bottom. So we get log base 6, x squared in the top because there's a plus one in front. Y cubed in the top because there's a plus 1 in front. X4 in the bottom because there's a minus 1. Y5 in the bottom because there's a minus 1. Then, x squared cancels off 2 of these. Y cubed cancels off 3 of those. When the numerator cancels off, what's left behind? A 1. Thank you. If anything. If you've left with no knowledge, I promise you, the knowledge you've left with is there was a 1 in the numerator and everything cancels. And I feel like that's a win. Been a good year.
Why didn't you lie to me?
I told you I didn't do it right.
And then I didn't say you did it right. I said if you leave this year knowing there's a 1 in the numerator, then it was a solid win. You know, I've lowered my standards within 5 minutes right there. This 5 minutes, I just lowered my standards.
Good, you should.
Sufficiently.
We should have done it a long time.
Yep.
No.
Wait, so what is that to the 4?
Yeah.
And a plus sign between the x and the y and the bottom?
No.
No.
There is no sense.
There's no sign at all. It's just all x4, y5. Okay, so what I want you to do for the last little bit is I want to draw your attention once again to the Friday assignment I posted. It's a review on everything, right? If you do rationals, then it has the answers after it. Then rational equations, it has the answers after it. Logs, answers after it. Exponentials, answers after it. And it has little hints, and it has the formulas on the side that you might want to look at, since some of you knew what they were. I draw your attention to the Friday review. It's a review on everything. In there is sinusoidal, which you don't have to worry about, but if you want to look at it, you can. And log word problems I told you I won't put on. Okay, so don't worry about log word problems, whether it's like a log, because I didn't make you do those, but the exponential ones are fair game. Yeah?
Do you have any practice tests posted?
I don't have any practice tests, but I have all those reviews, and then that review is posted.
What about Wordle?
We
What
we
if-
forgot to play the Wordle.
Oh, Wordle.
Get on it.